And with our new celestial companion in tow, Earth's journey was far from over. This giant impact hypothesis isn't just a cool story. It's the leading explanation because it so elegantly accounts for so much. The moon's surprisingly large size, its remarkably similar composition to Earth's mantle, and why it's still, ever so slowly, moving away from us today. Here's a quirky thought. That precise glancing blow was perfectly imperfect to give us our celestial dance partner. While this hypothesis is incredibly robust, scientists still debate finer points, like Thea's exact origin or if multiple smaller moons initially formed. The evidence remains conclusive on the overall scenario, but those details keep the astrophysicists busy. This key scientific event wasn't just a bump. It was a cosmic punch that vaporized most of Theia and ripped off a colossal chunk of Earth's own mantle. Think of it like two super hot, slightly squishy billiard balls colliding, one exploding into a molten, glowing shrapnel cloud, millions of degrees hot. A colossal ring of incandescent debris, superheated rock and metal, was violently flung into orbit around our bruised, still healing Earth. Over thousands of years, like cosmic dust bunnies slowly gathering, this swirling material began to coalesce, eventually forming the majestic orb we call the Moon. After Earth began to solidify its form, something truly mind-bending was about to happen. An event so cataclysmic, it literally reshaped our entire future. Imagine the early solar system as a chaotic cosmic demolition derby, where planetary building blocks were still figuring out their lanes. Then there was Theia. Not some tiny asteroid, folks, but a rogue protoplanet about the size of Mars. Yep, that Mars, on an unavoidable collision course with our brand new home. The impact itself, unimaginable, is an understatement. But within a few tens of millions of years, a blink of an eye in cosmic terms, our fiery, embryonic Earth was born, ready for its next dramatic act. This incredible process, known as accretion, is how our proto-Earth began to form. With every violent collision, every impact from another hurtling chunk of space debris, our planet grew larger, accumulating mass and transforming into a sphere of molten rock. It was a red-hot, undifferentiated world, seething with the energy of its violent formation. This wasn't an overnight job. Scientists still debate the exact speed of this process, with some theories suggesting it happened relatively quickly, while others argue for a more extended period. You watch, almost in slow motion, as microscopic dust grains, literally specks no bigger than the ones collecting on your furniture, gently bump into each other. But instead of just bouncing off, they stick, like cosmic Velcro. This isn't just a happy accident. It's the beginning of something monumental. These tiny particles coalesce, growing into pebbles, then boulders, then truly massive city-sized chunks of rock we call planetesimals. It's less of a gentle waltz and more of a chaotic cosmic demolition derby, with countless impacts reshaping the early solar system. You've just witnessed the birth of our star, the Sun, a fiery ball of fusion. Now let's zoom out slightly, just beyond its glowing embrace, and you find yourself in the solar nebula itself. Picture it, a colossal spinning cloud, a cosmic construction site made from the leftover gas and dust from the Sun's spectacular arrival. It's like a giant, ethereal donut, shimmering with the raw ingredients for everything we know. Here, gravity begins its subtle yet profound dance. This was a planet, forged in fire, shattered by a cosmic collision, and smothered under a toxic sky. Yet it was precisely this violent beginning that set the stage for everything that has ever lived. Scientists still debate the exact timeline and mechanisms through which the first oceans formed, with some theories suggesting that vast amounts of water were delivered by comets, while others argue it was trapped within Earth's mantle and degassed over millions of years. Eventually, as temperatures dropped, the first oceans boiled into existence, only to condense and rain down for millennia, slowly covering the fractured, cooling surface. The aftermath was astounding. Earth was reformed into an even hotter, completely molten sphere, while the moon formed in a matter of hours or days, initially much closer and appearing enormous in the toxic, steaming sky. Talk about a dramatic entry. As the planet slowly cooled, a thick, suffocating atmosphere of volcanic gases enveloped it, trapping heat and creating an environment truly alien. Imagine a molten ball of rock, glowing fiercely, constantly bombarded by cosmic debris. That's baby Earth, a true hellscape. This isn't just a story of rocks and chemistry. It is our ultimate origin story. The key scientific fact here is the giant impact hypothesis. Roughly 4.5 billion years ago, a Mars-sized protoplanet, often called Theia, slammed into our nascent Earth. This catastrophic collision ripped vast amounts of material into orbit, forging what quickly coalesced into our moon, a celestial companion born from unparalleled violence. If you enjoy content like this, don't forget to like and subscribe. It really helps the channel grow and lets us keep bringing you these epic tales. And hey, comment below where you're watching from, or tell us which natural mystery fascinates you most. Let's dive in and explore how it all unfolds. You are standing on a precipice, not of space, but of time itself. Before you lies a chasm 4.6 billion years deep. Forget the gentle blue marble you know. We're about to journey to the very bottom, to witness the birth of our world. Welcome to today's deep dive into an adventure billions of years in the making. If you think volcanoes only erupt on land, wait until you learn about the ones hiding under the oceans, silent, massive, and shaping continents as we speak. Today, we're not just exploring a place, we're exploring time itself, peeling back the layers of Earth's history to reveal its fiery, chaotic, and ultimately miraculous birth. This isn't just a science lesson. It's our planet's ultimate origin story, a cosmic drama starring rocks, fire, water, and eventually, life.